automatically the displacement which we have done is greater and the time required will be much more. So depending on this, this is the example of non-contact type of displacement measure. So there are again various types of displacement measurement, non-contact type of displacement measurement. In that one, we will consider one of the contact type also and non-contact type also. Piezoelectric type of transducer also can be considered for measurement of this one. Other than the provided one, that is your ultrasonic, then Hall's effect is there, optical one is there, proximetry sensors are there. Proximetry sensor may be capacitive type, it may be optical type, it may be inductive type. There are large number of proximetry sensors. We will see one or two proximetry sensors with examples of the proximetry sensors. So the first one which we are considering is the piezoelectric effect, and piezoelectric effect is nothing but this can be used as a transducer as well as inverse transducer also. Now, how this can be used as a transducer or inverse transducer? Because when we people are applying a force on this particular component or this particular transducer, the voltage in proportion to the applied force will be generated and vice versa of this. So there are certain materials that generates the electrical potential or voltage when a mechanical strain is applied. So this mechanical strain which we are going to apply, that may provide the displacement, and for the measurement how much displacement is arise depending upon the mechanical strain, that can be measured because the force is going to be exerted on the piezoelectric crystal, and here whatever the voltage which has been generated, that will be proportional to the displacement. So the basic concept is that when mechanical strain is applied, or conversely, then the voltage or inversely to that one, if you are applying a voltage, then and then also its dimensions are going to change, and this particular effect is called as a piezoelectric effect. This effect was discovered in 1880 by Pierce and Curie. So what is the concept for the displacement measurement? In both the way, inverse and non-inverse concept is provided over here. This is the piezoelectric effect which is shown in blue. Then direct effect and reverse effect is also provided, that when mechanical strain is applied at that time, it produces voltage or a sound vibration which is striking on this particular piezoelectric ceramic. So electric signal is going to generate. Now, how you are going to correlate this particular effect? If suppose whatever the sound which is generated, actually if we vary, suppose this is the position of the sound generation and this is our crystal. If I vary the position, this is nothing but this is the displacement of the sound generated signal. Now what is happening? If I reduce this one, the sound will bombard maximally with high intensity on this particular piezoelectric ceramic, and due to that one, the generated output will vary. If distance is far away, then the minimum sound vibration will reach to the piezoelectric ceramic, and the electrical output generated will be the minimum. Then reverse effect is that the sound vibrations, then again piezoelectric ceramic and electrical signal. This is nothing but the reverse effect. It means that if you are applying the electrical signal to this piezoelectric ceramic, then sound vibrations are generated, because in our Doppler system or ultrasound system, which we people are using commonly in medical field. Actually, these sound vibrations are generated and they are trying to create the image. So depending upon the position, you people are going to get the clarity, or you people can easily measure the displacement using your piezoelectric type of crystal. So the best example is heart sound measuring. In heart sound measuring, you people are placing one piezoelectric capacitive type of a sensor on the chest, and when you are placing it on a chest, at that time the pumping action of the heart, that is going to increase or reduce the vibration, and it will try to generate the output in terms of electrical signal. So back and forth motion of the heart during pumping or contraction and relaxation of the heart will increase or decrease the displacement gap between the sensor, and which will try to generate the output in terms of electrical. By this means, you can easily measure the variation in the displacement. The general structure has been provided over here, that how normally or generally your piezoelectric crystal works. So the piezoelectric transducer works on the principle of piezoelectric effect that I have already told you. When the mechanical trace or a force is applied on that particular piezoelectric material, what are the different types of material that I will provide you. And this particular schematic representation shows that the blue arrows are nothing but the force that has been applied on the piezoelectric crystal or material, and the output has been converted to the voltmeter, connected to the voltmeter. So depending upon the applied force, the charges or voltage is generated over here. So, so the material that are used for this one, piezoelectric effect. So the material used for the measurement purpose should possess the desirable properties. When we people are using for any application piezoelectric material, at that time you have to consider the following properties, so that the resultant output generated for measurement of any parameter using piezoelectric crystal will be much more effective, or that will be a feasible one. So first property, it should have a stable one, or it should have the proper stability. Then the output generated by that particular material should be higher one, insensitive to the temperature and humidity, and ability to be formed for the machine into any shape. Because depending upon the application, we people are going to mold that particular piezoelectric into proper shape. But this is not a feasible one to change the shape, but it should be insensitive to the temperature and humidity, because various shapes may not be provided with this one, but up to the mark we can provide the particular shape or the depending upon the application. So when atmospheric condition changes, at that time your temperature may change, your humidity may change, and these parameters should not affect on that material. And if that material is affected by these parameters, the output generated while measuring a particular physical parameter, that will show a false result. So the material should be insensitive. This property should be incorporated in that particular material. However, none of the material exhibits piezoelectric effect possess all these properties, because over here all these properties may not be feasible, but maximum properties when it is present, at that time you can use that one for a particular application. So what are the different materials that can be used? Barium titanate, lead zirconate and titanate, roselect salt, quartz. Quartz we people are commonly using in our watch, and roselect salts Rossel salt is also commonly used compared to the above two ones. Okay, so commonly used material because they seems to have the maximum properties which we people have provided regarding stability, high output, then molding in the shape, uh, insensitivity to temperature. These properties are incorporated in this particular material, and that's why you people can use that one. Okay. Now, how it can be used for the displacement measurement? So over here, we people are having one diaphragm is mounted over here. Here is the pressure. Why we people are applying the pressure? When we are applying the pressure on the diaphragm, automatically that diaphragm will provide you displacement. And below that diaphragm, one stick is arranged or one hard pointer is arranged below which actually piezoelectric crystal is mounted. And below that one, here is a base. Here is the base. Now, what is happening with this one? When we people are applying a pressure or a force on this one, it will try to deflect or generate a displacement over here. And when it is generating a displacement on this one, that displacement we people are interested to measure. So when we are applying a force that is creating a displacement and that displacement is exerting a force on the piezoelectric crystal, so this piezoelectric crystal will try to generate a voltage output. So here is the our voltage output that has been generated. Now this generated voltage output is proportional to the displacement which has been caused due to the applied force, which has been caused due to the applied force. So we are interested that the displacement generated by the diaphragm can be measured using piezoelectric crystal, and that displacement is calibrated in terms of voltage. So output voltage above the base, it has been shown. Likewise, you can measure the voltage voltage for the displacement measurement, which is, means that displacement is calibrated in terms of voltage. Okay. What are the advantages and what are the disadvantages of this particular one? High frequency response. They offer a very high frequency response. That means the parameter changing at very high speed can be sensed easily. This is one of the best advantage. Then high transient response. The piezoelectric transducer can detect the event of microsecond also, and also give the linear output for this microsecond results. The piezoelectric transducers are small in size and have a rigid construction. So this is also one of the significant advantage or merit of piezoelectric crystal. However, when one side of the transducer is having good things, then there are some negative things are also incorporated. So what are the negative things or limitations, demerits of this particular piezoelectric crystal? It has a low output, so output obtained from piezoelectric transducer is low. So external electronic circuit has to be connected for amplification of that particular signal, so that you can enhance that particular signal up to certain limit as per your requirement of the application. Then second limitation is a high impedance. Then in this one, your piezoelectric crystal have the high impedance, so they have to be connected to the amplifier and the auxiliary circuit, which have the potential to cause error in measurement. So to reduce this error, amplifier, high input impedance and long cables should be used. So remedies are also provided for this particular aspect. And one more which we people have discussed in the property for the forming of the shape, it is very difficult to give the desired shape to the crystal with sufficient trade. Okay. Now another